What is going on, guys? Welcome to your third physics tutorial, and in this lesson I want to start off by talking about some basic acceleration problems, and then I'm going to talk about something called the acceleration of gravity, an amazing phenomenon. But let's go ahead and take a look at this acceleration formula one more time. So we already know that in order to calculate acceleration, we need to figure out the change in velocity over the change in time. But just like velocity and speed, we can use this same formula to calculate acceleration or change in velocity or the change in time. So let's go ahead and take a look at a sample problem. Say that we started out at, I'll write all this info down, started at 0. This is supposed to be an at sign, a quite beautiful at sign if you ask me, at 0 meters per second. That was our starting speed. Basically, we started not moving at all. Simple enough. And then we decided to accelerate, so acceleration at a rate of 8 meters per second squared. So this is our acceleration right here. That's how fast we're accelerating. So we want to figure out how fast would we be going after 5 seconds. So for a time, we have 5 seconds. Well, using this formula, what do we want to figure out? We want to figure out the change in velocity after 5 seconds. What is our velocity? So let's go ahead and plug in this baby. So acceleration, we know, equals 8, and I'm going to leave out the meters per second squared in seconds for now. 8 meters per second squared. Now, the change in velocity is the thing we're trying to figure out, but what we do have is the time. So time equals 5, and I guess I might as well throw this in, seconds. So in order to get the change of velocity, what we need to do is we need to times the acceleration or multiply. Whenever I say times two things together, I mean multiply. I know I know it sounds kind of dumb to say I want to times 8 and 5, but hey, just guys got to deal with it, I guess. So let's go ahead and multiply 8 times 5 in order to figure out the change in velocity. So basically, the change in velocity is equal to 40, what I say, miles per hour, or no, meters per second. So after 5 seconds, accelerating at this rate, at a starting point of not moving at all, after 5 seconds, we would be going 40 meters per second. And you could also write it like this, meters per second or meters dash second. Either way, it's up to you. Take your pick. So I just wanted to show you guys that not only can we use this formula for acceleration, but also change in velocity and change in time as well. So now I think we got basic acceleration taken care of. Now I want to talk to you guys about something called the acceleration of gravity. The phenomena of gravity, actually gravity is a still pretty big mystery to physicists and chemists and a bunch of scientists, but we have the figures that we can crunch. So we know this. Whenever you have an object that falls from the sky, these are clouds right here, and this is an object. What is it? I don't know. Take your pick. And it's falling from the sky. We know that its acceleration is 9.8 meters per second squared. Now, I just didn't come up with this figure right here. A bunch of nerdy people figured this out, that the acceleration due to the force of gravity anywhere on Earth is 9.8 meters per second squared. Seriously, they figured that out, not me. So basically, if we were standing on top of a building, guys, you better prepare for like the worst drawing ever. Say we were standing on top of a building. Let me draw a little dude. That's me, up there. Hey, look at me. And we decided to drop a can of tuna off the building. Well, let's go ahead and figure out the speed of that tuna after 1, 2, 3, 4, 5, 6, 7, 8, 9, a bunch of seconds. So time, and we'll say that the time is seconds, and the speed, we'll just say this is in meters per second. Now, remember the information I gave you guys already. The acceleration due to gravity anywhere on Earth is 9.8 meters per second squared. So that means after 1 second, this can of tuna would be going 9.8 meters per second. After 2 seconds, the speed of this can of tuna would be going 19.6 meters per second. That's a pretty fast can of tuna. Now, after 3 seconds, how fast would this can of tuna be going? It would be going 29.4 meters per second. And after 4 seconds, it would be going 39.2. And you can go on and on and on, but I don't want to waste your time. Basically, what you do is you add 9.8 to this each time. Now, let me go ahead and show you guys this graphically because it isn't exactly what you guys might expect because it's a little bit different. So at 0 seconds, let's just say at 0 seconds, let's just say it's right here. You are holding the can of tuna. You just dropped it immediately. Now after 1 second, we'll say 1 second, the can of tuna is right here. Now at this point in time, it's traveling at a speed of 9.8 meters per second. Now after 2 seconds, the can of tuna is down here. Now notice that this gap right here is a little bigger than this gap right here, and that is because it picked up speed along the way. So now it's traveling at a speed of 19.6 meters per second squared. Now after 3 seconds, the can of tuna would be somewhere like way down here. So even though the speed looking at the graph looks kind of constant, and yeah, looks kind of constant, it kind of isn't, and it's kind of deceiving. So I think my can of tuna is changing in size a little bit, but that's alright. So after 3 seconds, this can of tuna would be traveling at a rate of 29.4 meters per second. So I just want to kind of show you guys a visual of what would be going on here. Even though the acceleration is kind of constantly moving up, the distance from the person is not the same from 1 second to 2 seconds, then 3 seconds. It's moving further and further away, and that's because, like I said, the speed of the tuna is increasing. It starts out going really slow, and then by the end of 4 and 5 seconds, it's traveling at a really fast rate. So it travels away from you faster. So just keep that in mind, and that's a difference between a constant speed and constant acceleration. Constant acceleration means that things are speeding up, traveling away from you faster and faster. So I just want you guys to soak that in for a little bit. Go home and, well, you guys are probably home. Go get something to eat and soak in this information. And what I'm going to do is I'm going to take a drawing class. So in the next lesson, hopefully I draw a little bit better. So anyways, thank you guys for watching. And don't forget to subscribe. And I'll see you guys in the next video.